In this video, we'll look at how to solve a revenue word problem using quadratic formula. This video is by request. A lot of my students have trouble with this stuff, so I guess follow closely. So I've picked number 3 from a handout we do. I'll read it to you. A bus company has 4,000 passengers daily, each paying a fare of $2. For each 15-cent increase, the company estimates that it will lose 40 passengers. If the company needs to make $10,450 per day to stay in business, what fare should be charged? Okay, first things first, we got to set up our equation. Remember, always, revenue is calculated by just going price times number of items. That's true even if you hadn't taken math. How much money you pull in is whatever you sell things for times however many you sell. But it gets a little tricky in the context of math and a word problem. We've got to see the price here. In this case, it's $2, but there are price increases. So let's create a variable. We'll call it x. Let x represent the number of increases. Okay. So the price was, where are we here? Question 3, $2.15 for every increase. So we write that in math as 2 plus 0.15 times x. Let me read that back to you. The price of these things, whatever they are, it doesn't even matter anymore, we're just going to work with the math, is 2 plus 15 cents every time we increase the price. Now for how many items are sold. Go back to the question. There are 4,000 fares sold. It's 4,000 passengers, each paying a fare. So we have 4,000 items, but every time they raise the price, they lose 40 passengers. So we write that in math as 40,000 items minus 40 for each price increase x. I'll go over that equation. The revenue, I'll write it here as well, is $2.15 for each price increase times 40,000 minus 40 items for each price increase. And that's our revenue function, but we're going to work with it a bit more. We got to expand it and simplify. There's videos on this, expanding using FOIL. We're going to rainbow or FOIL 2 times 4,000 gives 8,000. And now 2 times negative 40 gives negative 80, and there's an x there, so negative 80x. 0.15 times 4,000, let's pull out the trusty calculator. 0.15 times 4,000, and you get 600, so that's plus 600 x's. And now 0.15, didn't even need the 0 there, times negative 40 gives negative 6. And just check me on this, it's 0.15 times 40, but also x times x, so you get negative 6x squared. Let's rewrite this equation with descending exponents, like we write parabolas always, the x squareds first, then the x's, so we got 600x minus 80x, you can do that on your calculator in your head, that's plus 520x, and then finally that 8,000, which is positive, so put a plus here. Now we have a nicely formatted parabola, and we have to solve it, but we don't want to just maximize revenue or minimize something. It's not that. It's the company needs to take in $10,450 a day. So what we do is sub that in over here for revenue. Their revenue has to be $10,450. We rewrite the rest of the equation. And now, here's the key thing. We're going to solve this by first getting everything to one side. I'm going to subtract 10,450 both sides. So I have 0 here. And then I have negative 6x squared plus 520x. Again, you can solve it in your head or use a calculator. I won't judge you. Negative 2,450. Okay. Solving this won't tell us the zeros, but we're going to solve it just like you would solve any other quadratic using quadratic formula. But those answers will tell us what they need to charge, how many increases there's going to be. And so we'll solve a problem. Let me be clear on this. We're solving for the actual answer using quadratic formula, but it won't be the zeros. It'll solve this, is what x is needed to get 10,450. Let's see that in action. X equals negative b. Know your quadratic formula. Plus or minus the square root of b squared minus 4ac all over 2a. Sub in. Negative b. That's negative 520. Plus or minus the square root of 520 squared. And there's videos on quadratic formula, but check this. Make sure that if the b's negative, you put brackets. If it's not negative, don't need it here. Minus 4 times a, which is negative 6. I'm just getting this right from the equation, right? That's the a, that's the b, that's your c. So I got negative 4 times negative 6 times negative 2,450. Make sure that your root goes the whole way and that your fraction goes the whole way, covering all the numbers. And then 2 times a, that's 2 times negative 6. So I get x equals negative 520 plus or minus. I'm going to do everything inside the square root there. 520 squared. And notice here it's going to be a minus times a minus times a minus, which I know is a minus. I'm just going to put one single minus. Minus 4 times 6 times 2450. And I get 211,600 all over on the bottom, negative 12. At this point, I split it into two pieces. Show arrows, and let's put a separating line here. Again, I'd watch the video on quadratic formula if you don't know what I'm doing. Either x is negative 520 plus the positive version, 211,600, all over negative 12, or x is negative 520. Notice it's only the second thing, the root, that changes sign. It's either plus that root or minus that root, all over negative 12. And now I'm going to use my calculator. I like setting it up first, and so I don't forget my rounding dots. This is the only time I'm rounding. I put rounding dots on that last line. What's negative 520 plus the square root of 211,600? Don't forget to heat equals. Divide by negative 12. And I get positive 5. Oh, look at that. I didn't even need to round. Didn't see that coming. Better take that rounding dot away. Cleanly erase that. I don't actually think it's that cleanly erased. I did my best there. I'll cover it up with an x. There we go. X equals positive 5. And how about this one? Negative 520. Now I'm doing the negative version. Take away the square root of 211,600 equals first, then divide by negative 12. And I get 81.66. You know, I can avoid a rounding dot here too. That's a repeated decimal. I'm going to write it without a rounding dot and just write the symbol for repetition. So x equals 81.6 with a line over it, which signifies 81.6 repeating forever. And those are my answers for x. But let's go back to the question. The question says, what fare should be charged so that they get that amount of money? And what we solved for was the price increases, the x's, so that they get this amount of money. So let's calculate the actual price separately for both. The price of this one, how do we calculate price? It's $2 plus 15 cents per price increase. So price equals 2 plus 15 cents times 5. And you can do that in your head or on your calculator. 2 plus 15 cents times 5 gives $2.75. And how about this one? Price equals $2 plus 15 cents times, and now it's 81.6666 repeating, which is, what's 2 plus 15 cents times 81 point, a lot of sixes, equals, nice, 14.25. So if you notice, we've solved the two prices that give this amount of money, anything between there, and they stay in business. What was the question? Question, the last part, the company needs to take this much in per day to stay in business. So as long as they charge this or anything in between it, if the company charges between $2.75 and $14.25, they stay in business. We did it. We solved a question. Let's finish writing that. We solved a revenue word problem using quadratic formula. We wrote the revenue expression. We subbed in the value we were trying to solve and got it all to one side, so equals 0, which means we can use quadratic formula, and our solutions, these x's, solve the case of when the revenue is $10,450. We had to do a little extra work to figure out the price, but we got it.